Hey chat, this is Le, one of the teachers of Chemistry 4, Frontiers of Chemistry. We're glad to have you join us as we learn more about chemistry as it plays in the real world and society. For the first quarter, we will be learning about analytical chemistry, or the branch of chem that allows chemists to accurately describe the chemicals that they are dealing with. This is our first lesson, so strap yourselves in, besties, and welcome to Ana Chem. If you dug up some ore and you suspect that it contains some gold, who do you approach to have that verified? Chemists, of course. Chemists are trained in analytical chemistry, or the branch of chem dealing with obtaining and processing information about composition. In this case, the gold is called the analyte, or what is being sought after, and the ore is the sample, or what is being tested for the analyte. Throughout the rest of the quarter, we will look deeper into chemical analysis and learn more about how that gold could be measured. Every chemical industry needs information about the chemicals they're producing or handling, such as the purity of medicine or the nutrition in food. This is why a discussion on analytical chemistry is our first goal in class before we even proceed to discuss chemistry in other parts of society. At this point, let's talk about the 7 major steps in a chemical analysis. First and foremost, you need to choose a method. There are various methods with different accuracies, analysis times, costs, and purposes. A quantitative method would have you determine the concentration of the analyte in a sample, while a qualitative method would simply have you determine the presence of a substance. Each method has its own protocol to ensure accuracy, so you really need to decide what method you want to use before you can even proceed. Second, you need to acquire a sample. You cannot just analyze the whole ground for gold. That's just silly. A sample is representative of the overall picture, and it's essential in all chemical analysis. Third, you need to process the sample. It's not always the case that you can measure the analyte directly from the sample. Sometimes you have to do grinding or filtering or adding other chemicals. The gold ore, for example, may need to meet aqua regia, a very strong acid mixture, to ensure that all the gold can be in a form that is measurable. Fourth, you need to eliminate interferences. When you put your sample inside the machine for analysis, how much of the result describes gold and how much of it actually describes something else, like silver? An interference is a substance that can increase or decrease the value of the result of the analyte. In any case, it will pose problems for the accuracy of the results. Fifth, you need to calibrate and measure. Calibration is a process that helps you ensure that the results you will get this time around will be comparable to results you will get some other time. Calibration is a step that many students overlook in their research. You can only gain confidence in the results of your analyte if you have done calibration beforehand. Again, you need to calibrate first before you can measure. Sixth, is this working? Sixth, you need to calculate results. It's not always the case that the results you will obtain from your chemical analysis are in the form that you want them to be. Maybe you have to process them in a computer, or maybe you have to do some stoichiometry. Seventh, you need to estimate and establish reliability. For quantitative analysis, you need to conduct statistics so that you could express the uncertainty in your values. Even for qualitative analysis, you need to describe the accuracy of your results. It is in these 7 steps that chemists all around the world are ensuring safety and quality in all things chemical. Think of all the environmental scientists making sure that our rivers and oceans do not have poison in them, or the cosmetics chemists making sure that the stuff in your skincare won't damage your skin. We'll learn more about these 7 steps, particularly in the context of various chemical methods throughout the first quarter. I hope I was able to give you a good overview of analytical chemistry and I got you excited of what's to come. This has been Le, and I'll be seeing you soon.